Lesson 3.4, part 2. We're dividing polynomials, but this time we're using synthetic division. And in fact, this first problem we're going to do is one of the problems we did yesterday. It was the first polynomial problem we did long division yesterday. So the answer will be this familiar. Now, with synthetic division, the idea of synthetic division is we get to drop out the variables and just work with the numbers. Okay? So, when we set up synthetic division, now, I will say synthetic division only works when you're dividing by something of the form x minus a. So it has to be x minus a number. So it only works for some of the long division problems we did yesterday. Like yesterday at the end of class, we divided by something like 4x squared plus 9. That doesn't work for synthetic. That you have to do long division, but this works. So first thing we're going to do is we're going to set up a little box here. And this box represents what we're dividing by. Now, we're dividing by the factor x plus 5, right? If you think about x plus 5, setting it equal to 0, what does x equal in that scenario? You subtract the 5 over and x equals negative 5, yes? Negative 5 is what is going in my box. And that's the easiest way for me to connect it. But realize this is of the form x minus a. So you're always going to take the opposite sign from your divisor. So since this is x plus 5, I'm putting a negative 5 here. Okay. Now, next to this box, we're going to write numbers representing each of these terms. So basically you're writing your coefficients in order. So here, the coefficient of my x squared term is 4. The coefficient of the x to the first term is 23. And then the constant term is negative 16. So you always just basically drop off the variables in order. Now, you might have to use placeholder zeros on occasion because we need every place value to matter. And with no variables here, you have to have placeholder zeros to make it work. Okay, now, leave room for a row of numbers, and then draw a line. And this is our setup for synthetic division. Okay, first thing we do. You always start by taking your first coefficient here, so in this case, the 4, and we're going to drop it down to our answer. So 4 represents the first part of our answer. Then, we're going to do a multiplication step. We're always going to multiply by whatever's in our box, which in my box is negative 5. So we're going to do negative 5 times 4. What is negative 5 times 4? Negative 20. And we're going to bounce it up, and we're going to put it above the line in the next column. So in this case, it's going under the 23. So we multiply. Our next step is to add. Opposite of what you do in long division, yes? Long division we subtract. Here we're going to add. And I don't normally put the addition signs in, but I'm just trying to give you some tips here. What is 23 plus negative 20? 3. And guess where the 3 goes? Below the line. That's the next piece of your answer. Repeat the process. Now I'm going to take negative 5, and I'm going to multiply it this time by 3. What is negative 5 times 3? Negative 15, and I'm going to put it where? I'm going to bounce it up into the next column above the line, so it goes below the negative 16. And now we're going to again add. What is negative 15 plus negative 16? Negative 31. Okay. 4, 3, and negative 31 represent your answer. Guess what negative 31 is? It's your very end thing. It is your remainder. Okay. That last spot always represents your remainder. So negative 31 is our remainder. 4 and 3 represent the coefficients. So we're going to put our variables back in. Now, Keep in mind, this original 4 represented 4 what? X squared. We just took 4x squared and divided by an x. So that means 4x squared, you divided by an x. This is now 4x to the first. In other words, right here, your first piece of your answer is always going to be 1 power less than what you started with. Because I took a 4x squared and I divided by an x to the first. So it's always going to be 1 power less, and that's 4x. So 4 is 4x. What comes after x? 3 is your constant, plus 3. And then remainder. No, I'm not going to say r negative 31. What did we do yesterday? What do you remember, Emily?
Negative 31 over negative 5.
Not over negative 5, but right idea. What does negative 5 represent? The x plus 5. So it's still going over that original divisor, x plus 5. So 4x plus 3 minus 31 over x plus 5. If you flip back to the first polynomial long division we did yesterday, same problem, same answer. The middle part looks 100% different, doesn't it? Okay. Questions there? We'll go through some variations. We'll look at some pieces there. Yes?
So it says divide by x plus a, but this one it's x plus a. What is that?
X minus a is just the representation.
Is it just
Okay.
saying the number has to be negative?
The number has to be so the form of this problem is minus. So it's always going to be x minus some value. And so in order for, since this is x plus 5, that's the same as saying x minus negative 5. Okay, it's always x minus some value is the form there.
So it's just x.
Yeah. The easiest thing to think, you're always going to be using the opposite sign when it's in that form of x plus or minus there. Okay? Okay, shall we try B? It wasn't horrible, was it? It's different. It'll fly by once you get to catch on to the technique. Which give us another example or two and you'll be there. Okay, so x cubed minus 14x squared plus 51x minus 54 divided by x minus 2. What goes in my box?
2.
So I always think of this as setting it equal to 0. X minus 2 equals 0. So then if I solve it, it's going to be positive 2. Yes? Always the opposite sign when they have in that form. Okay, row of numbers. What's my row of numbers here? First coefficient is invisible 1 in front of the x cubed. In front of the x squared is negative 14. In front of the x is 51. And the constant is negative 54. Leave yourself room for a row of numbers and draw your line. Okay, do you remember your process? Always start by dropping that first number down. First number down, I'm dropping down is 1. Then, once you drop that first number down, the step is multiply. We always multiply by what's in the box. So 2 times 1 is 2. And that goes up above the line in the next column. What do I do with negative 14 and 2? We're going to add, yes? It's always multiply, add, multiply, add, multiply, add. Don't let that be confused with long division though, right? Negative 14 plus 2 is negative 12. Now what? Repeat. 2 times negative 12 is negative 24. And 51, what do we do with 51 negative 24? You add. What is 51 plus negative 24? 27. Repeat again. Always go back to 2. 2 times 27 is 54. Negative 54 plus 54? 0. What is that 0? That's my remainder, yes? Is it possible to have a remainder of 0? Yes, it happens sometimes. Okay, it just means I don't have to write a remainder. Okay. Are we good? Now, sometimes I feel like one of the hardest parts is how do we write our answer? What does this 1 right here represent?
X squared.
And why is it x squared this time? That 1 was originally an x to the third, yes? So if my original problem was x to the third, I divide an x, this is now an x squared, right? So what's this answer read? 1x squared, or x squared, then what? Minus 12x plus 27. Okay. Okay, ready for the next one? Don't get too far ahead of me on the setup here, unless you've already caught the trick. Okay, what goes in the box? What goes in the box? 3. X minus 3 equals 0, if that helps. So opposite sign, 3 goes in the box. Okay, what about my row of numbers here? First spot is the 2, which is in front of the x cubed. Then what? Negative 7 for x squared. Then what?
0.
Why is there a 0? I don't have an x to the first. So 0 is a placeholder. It's necessary. You can get away without it in long division. Not going to argue. It's rough, but you can get away without it. You need it here. So 0, and then what comes after the 0? Negative 4, because then you're ready for your constant. Okay? 2, negative 7, 0, 4. Or negative 4. Okay. Do the math. What am I doing? Drop the 2. And then what? Multiply. 3 times 2 is 6. Then what do I do with negative 7 and 6? We're going to add. Negative 7 plus 6 is negative 1. And then we're going to multiply. 3 times negative 1 is negative 3. And then we're going to add. 0 plus negative 3 is negative 3. And now what? We're going to multiply. Back to the 3 always. 3 times negative 3 is negative 9. And then we're going to add. Negative 4 and negative 9 is negative 13. Okay. What is that negative 13? That's your remainder, yes? Okay. Where's my answer start? 2 what? 2x squared, because original problem was x to the third, so 1 power less, so 2x squared. Minus what? 1x or minus x minus 3 is the constant. And then what?
It's 13 over x minus 3.
Okay. Minus 13, which is the remainder, over the original divisor of x minus 3. Okay. Another thought, I've been suggesting that, okay, if it started x cubed, it's now x squared. You could also start from the end and count back in the fact that negative 13 is a remainder, negative 3 is the constant, negative 1 is x to the first, 2 is x to the second. You could always count back that way too. Okay, we getting it? Okay, I'm trying to make sure I don't go too fast, but I don't want to bore you to death either also. Okay. D, 3x cubed minus 5x plus 10, all divided by x minus 1. What are you putting in your box?
1.
A 1. This is x minus 1, so if I said equal to 0, we're going to use x as 1. What about my row of numbers? What do I start with? 3. What comes next? 0. Because what are we missing?
The
X squared, yes? Did we catch that? So 3x to the third, 0x squared, and then negative 5 and 10. What's your first step?
Drop the 3.
Drop the 3, and then we're going to multiply. 1 times 3 is 3. Bounce it up under the 0. Then we're going to add. 0 plus 3 is 3. And then I'm going to multiply. 1 times 3 is 3. This is a lot of 3's. Then we're going to add. Negative 5 plus 3, negative 2, something different. And now we're going to multiply. 1 times negative 2,
Negative 2.
and 10 plus negative 2 is 8. Okay. What are you thinking? 3x squared. Keep going. Plus 3x
Minus 2.
minus 2
Plus 8 over x minus 1.
plus 8 over x minus 1. Okay.
I like that more. I like this one more than the other.
I'm going to be shocked if someone says I like long division better. So,
This just makes more sense.
Wait, could we
It
just do this instead of doing
well, here's the deal. Synthetic division will work as long as you're dividing by just a linear, like an x plus or minus a number factor. It doesn't always work though. Like if you look back to the notes we did yesterday, it wouldn't work on the 2 on the back. Because one of them was like a 4x squared plus 9, and the other was dividing by like 2x plus 3 or something.
Yeah.
It doesn't work in those scenarios as easily.
It has to just be x.
There's a trick it could be if like the 2x plus 3. There's a trick we could do, but we're just worrying about x plus or minus right now. Okay? Okay. You got the basics here, yes?
Yes.
Okay. 2 topics. We're going to talk about the remainder theorem. We're going to talk about the factor theorem. The remainder theorem says if a polynomial, p of x, is divided by a linear divisor, x minus a, then the remainder, you can't see it here, it's hidden by the recording. The remainder is p of a. Now, we're going to look at this in 2 different ways, but the idea is if you have a polynomial, so some function, divided by some linear divisor, x minus a, the remainder is p of a. we can find P of A by just plugging the number into the equation. And that will find your remainder. That's what the remainder theorem is saying. However, we also have synthetic division, which is pretty easy. And we can find the remainder that way. So, in example A, okay, they give us the polynomial P of X, and they give us, I don't like the way they do this, but they give us this C value of -2. And they say find P of C, so basically they're using C instead of A, by two different ways. A is by direct substitution, and B is by the remainder theorem, which is basically we're going to talk synthetic division. Okay? Now, I want to talk about A first. So direct substitution. They want us to find P of C. Well, what is C in this particular problem? -2. They want us to find P of -2. Now notice, this isn't X minus 2, is it? Or C minus 2, is it? This is C equals a number, right? When they give you C or A equals a number, you use that number as is. Don't change the sign. So, direct substitution says I can just take -2 and plug it into the equation. So, in P of X, every place I see an X, what are we going to replace with? -2. So, we can do -2 to the third plus 8 times -2 squared plus 12 times -2 plus 5. Doable, yes. Let's do the math real quick. -2 to the third is -8. -2 times -2 is 4 times -2 is -8. -2 to the fourth is, strike that. -2 to the second is 4 times 8, 32. 12 times -2 and plus 5. It can be done without the calculator. My brain says -8 and -24 are -32, plus 32, 0, and then plus 5. Okay, so that right there, that P of -2, folks, this is the remainder theorem. That's saying if we were to do the division, the remainder is 5. Now, that was by direct substitution. That wasn't horrible, was it? Other than maybe you get bigger numbers, maybe you have to grab the calculator out, right?
Okay, so that was just for the
That's a way to find the remainder. Now, part B talks about the remainder theorem. And when I'm going to talk about the remainder theorem here, I'm going to talk about doing not long division, synthetic division. What about the PSAT? Talk about the remainder theorem, maybe?
Not the remainder theorem, but like they gave me one where it's like f of x and I like one instead of x.
Okay.
And I did not remember how to do that.
Okay.
It was algebra 1, I know it was, but I just.
But it wasn't clicking there. Okay, fair enough. Okay. Let's do this problem with synthetic division. Now, key point, what goes in the box? -2. Use, it says C equals -2. Don't change the sign. Use it as is. What numbers go next to my box? 1, 8, 12, 5. Okay. Do the math. We start by what? Dropping 1. Multiply. -2 times 1 is -2. 8 plus -2? 6. -2 times 6? -12. 12 plus -12? 0. -2 times 0? 0. 5 plus 0? 5. What do we just discover here?
Remainder is 5.
The remainder is 5. Now, same answer both ways, yes? Does it matter which way you do it? No. Okay? So what I'm trying to get you guys to realize, if they ask you to find P of C and C is negative 2, if they ask you to find P of negative 2, you can plug it in. However, you could also do synthetic division. Both work. Okay? Some of it may depend if you have a calculator by your side, you know. Okay, let's look at B. For the given polynomial in the given C, use the remainder theorem to find P of C. So when they say find P of C, where is C? Do you see it? Sorry, bad setup on my part. Negative 5, right? So what is, they want us to find P of negative 5. What is one option? Can you do substitution? You can. Negative 5 to the third plus 10 times negative 5 to the second plus 29 times negative 5 plus 24. Is that the route you want to go? I don't know. Maybe it is, maybe it isn't. If that's not the route you want to go, what's the other option? Could you do synthetic division? Yeah, what goes in your box? Negative 5, because they gave you the value. They didn't give it as a factor. What numbers go next to this?
0, 10, 29, 24.
Someone correct his first value.
1.
1, right?
Yeah.
Only 0 if it's missing.
Yeah.
X cubed has the 1 x cubed. Okay, so you got your process down, right? Are we pros at synthetic division now? Drop the 1. Negative 5 times 1 is negative 5. 10 plus negative 5 is 5. Multiply. Negative 5 times 5 is negative 25. Add. 29 and negative 25 is 4. Negative 5 times 4. Negative 20. 24 plus negative 20. 4. What's my answer? 4, yes? The answer that we're looking for is 4. Now, would you have gotten the same thing over here? You do. Okay. Negative 5 to the third is negative 125. Negative 5 squared is 25. Times 10 is 250. 29 times negative 5 minus 145 plus 24. Synthetic division was probably a little easier and quicker for you, wasn't it? Okay, it is for me, I know. Negative 125 plus 250 is 125. 125 minus 145 is negative 20. Negative 20 plus 24 is, guess what? 4. Have I proven my point? It doesn't matter which way you go?
Yeah.
Now, I'll be honest. If you ask Savas for help, if I recall correctly, I think they had you plug the value in. Just saying. Can you do that? Yes, but when you see them start plugging the value in, also realize you could probably do synthetic division too. Okay? And they're just looking for the remainder. Okay. Backside. I feel like I'm running behind in your class. Okay. That was remainder theorem. Options of how to find the remainder. Okay? Now we're going to talk about the factor theorem. I mentioned this idea yesterday. The factor theorem says the binomial x minus a is a factor of p of x if and only if p of a equals 0. What is that equal 0 saying? They're saying if the remainder is 0. Something is a factor if the remainder is 0. Okay, so use synthetic division and the factor theorem to determine, is this a factor? So in A, they give us P of X, and then they give us the binomial X minus 4. We want to know, is X minus 4 a factor? So to know, is X minus 4 a factor, I want to know, is the remainder 0? How would you like to find the remainder? Synthetic division sounds like a grand idea. Okay, quickly, what goes in the box?
4.
This time it's 4. Are you catching the difference, right?
Yeah.
Because how was it presented? It was presented as the X minus 4, so then think in terms of solving. Okay, what numbers go here?
1, negative 10, 28, negative 16.
Okay, and you checked. There was nothing missing, right? X cubed, X squared, X constant. Drop the 1 and multiply. 4 times 1 is 4. Negative 10 plus 4 is 6 of the negative variety. 4 times negative 6, negative 24. 28 plus negative 24. 4. Multiply again. 4 times 4 is 16. Negative 16 plus 16. 0. What just happened?
Remainder of 0.
A remainder of 0. Okay. What does that tell me because there's a remainder of 0?
Yes, it's a factor.
Yes. Remainder of 0 means X minus 4 is a factor. Okay? So remainder of 0 means X minus 4 is a factor. Now, those of you that have done the long division homework, did you have to do a factored form somewhere along the lines, I think? Maybe not, but pops up today then. Factored form. What did we just say is a factor? Because we got a remainder of 0, we said that X minus 4 is a factor, yes? What's the other factor? We divided by X minus 4 and got what? That 1, negative 6, and 4? What do 1, negative 6, and 4 represent? The other factor. It's going to be 1x squared minus 6x plus 4. This right here is what factored form would look like. If you didn't see it in last night's homework, I think you'll see it in tonight's homework.
I remember.
Okay. I feel like it's in both homeworks is what I was kind of thinking. But that's what factored form is. It's taking the two factors and just writing them next to each other. Got it? Okay. One last example. We can do it. They give us a new P of X and a new binomial. We want to know, is X plus 5 a factor? So how are we going to figure that out? We're going to find out there's a remainder. I'm going to use synthetic division. What do you want in the box? Negative 5, because again, it's X plus 5, so use negative 5. What goes in the line?
2, 9, negative 2, 6, negative 4.
Okay, no missing pieces, right? Okay, drop the 2, multiply. Negative 5 times 2, negative 10. 9 plus negative 10, negative 1. Multiply negative 5 times negative 1, 5. Add negative 2 plus 5, 3. Multiply negative 5 times 3, negative 15. 6 plus negative 15, Negative 9. Multiply. Negative 5 times negative 9. 45. Add. Negative 40 plus 45. 5. What do I know about 5? It's not 0. What do we know since the remainder is not 0? It's not a factor. So the remainder is not 0. Since the remainder is not 0, I'm just going to say thus not a factor. Okay? We like that because then we don't have to do factored form. Right? Okay, guys. That's synthetic division. Enjoy it when you can use it, right? Okay. So, this week, 3.3, 3.4, part 1, both listed as due tomorrow. 3.4, part 2, listed as due Thursday. Review worksheet I'll hand out tomorrow is due Friday. Quiz is Friday. Are we all cool?
Yes.
Okay.